So yes class, in previous lecture we have done with the reaction of the HNO3 with the metals. Yes, so I have given you the trick that is you are supposed to learn. Now today we will start with this properties of HNO3, reaction of HNO3 with non-metals. So there also the same concept we have to apply. Okay, the same thing, and there will be no dilute and con concentration wala koi concept nahi hoga. Whatever it is dilute or concentrated, it will give you NO2 only. Okay, so let me start with the equation. Like first equation, if I'm giving you, suppose that I2 with iodine HNO3 when it reacts. So what I told you, that the must product will be, since nitrate is there, so obviously the must product will be here NO2. Yes, and since it is acid, so water will be there. And next thing, in the case of metal, yes, we were making that metal, we were making the nitrate, and wo bhi, that was the metal was in its highest oxidation state, isn't it, with the nitrate. Here also non-metal will form its highest oxidation state, but not with the nitrate, because nitrate is also non-metallic and is non-metal, so there cannot be a bond between non-metal and non-metal. So what we will say here also, that one concept is that non-metal will show its highest oxidation state. So let me write here, with nitric acid reaction, non-metals will give its highest oxidation state. The first thing, first concept, highest oxidation state. And the second concept is that non-metal shows its highest oxidation state. Non-metal shows its highest oxidation state in its oxo acid. So as I told you, the concept of this oxo acid, that means such acid which will give you hydrogen, but that hydrogen should be attached with the oxygen. Got it? That I have told you. So we will make the compound like the oxo acid, I told you. So it will show hydrogen, it will give hydrogen, and oxygen attached hona chahiye, so oxygen is there. And what non-metal is there? Iodine. So iodine, like these three elements we have to mix, and we have to make a compound like the iodine will show the maximum oxidation state. Here I am going to tell you that iodine, although that it belongs to the 17th group, sorry, so it should show 7 oxidation state, plus 7 oxidation state. So you can make like, yes, plus 7. But for this concept, whenever I will teach that group 17, there I will tell you it can show plus 7 till plus 7, but it is not the stable one. Got it? So plus 5 जो है वो maximum stable होता है. If you are making that if you are making this HiO4 where the oxygen is plus 7, that is also not wrong. It's not wrong at all. Okay, but the stable condition, HiO4 will break into the compound and it will give you HiO3, where the iodine is in what? Plus 5 state. So that is again the highest oxidation state. Got it? And here it is plus 7. So I told you that this can be also correct, but the thing is that if you will write, it will break into the compound and HiO3 and the other compound will give you. So that's why we will make HiO3 the stable one. Now if let me ask like S8 and HNO3. So tell me now, I think you can tell me. So the must product is NO2 for sure, and water will be for sure, and another compound will be H, S and O. Make a compound where the sulfur shows maximum oxidation state, and we know that sulfur has maximum oxidation state plus 6. So what is that compound? Yes, very good, it is H2SO4, isn't it? Similarly, if I am taking P4 plus HNO3, tell me what it will be. NO2 for sure, H2O for sure, and what next? This is H and P and O. Mix this compound, mix this element, and make a compound where the phosphorus will have the maximum oxidation state, and the maximum oxidation state is +5. So what will be the compound? Tell me fast. Yes, it is S3PO4. You have to think. So here it is +6, +7. Yes. And if we do the reaction with this Cl2 plus HNO3, tell me. Again the thing. And you can make the +7 maximum state. So there will be, you will say that here you said that HiO3 will be stable, and here you are making 7. So why so? So I just want to tell you, in this group 17, although they can show plus till +7, every element except fluorine, bromine, iodine, सब show कर सकते हैं, but only the chlorine become like due to this electronegativity, okay, it can show +7. बाकी जो होते हैं, they are stable in, like iodine and bromine, they are stable in +5 state only. Got it? So this is the reaction of, with this, what we can say, with the reaction of nitric acid with the non-metals. Okay. Now the last reaction of this NO3 and nitrogen group we will do, and that is brown ring test. And obviously the school is closed, so you people can couldn't listen or couldn't hear this word, but in class 11th you have done brown ring test, isn't it? Nitrate test. So let's do this equation, and this is with the like with respect to practical, it is very important. So here it is, brown ring test. This is like what it is. It says that it is the confirmatory test of NO3, first of all. Okay, it is the confirmatory test of NO3, and second thing, it is like what we say, how to do confirmatory test. It will give you the a ring like structure on the junction of the two liquid. Okay, kaise? Let's see. For this, the freshly prepared FeSO4, this is very important, freshly prepared FeSO4. And if you could remind this thing, recall this thing, why we were using this freshly prepared, I have explained in class 11th practical. Okay, so we have to take freshly prepared FeSO4 solution and add it to the salt solution. We will make the salt solution which is having nitrate, and after which the concentrated H2SO4 is poured along the wall of the test tube. This is also important, so that it shouldn't mix, otherwise it will mix and it won't give the ring like a structure, instead of rather it will give the brown compound, brown we can say solution. Okay, so like to stop this brown ring to be mixed, okay, what we do, we pour the H2SO4 through the wall of the test tube, then a brown ring formed at the junction. Okay, एक junction का बनेगा. So what is the reaction? It is important with this reaction, as well as viva में भी बहुत important question है. This is NO3 minus. This is NO3 minus is present in the salt, whatever the salt solution we have taken, any maybe lead nitrate, like maybe what we say, copper nitrate or zinc nitrate, we can take anything. So nitrate is there. It will be, I said freshly prepared FeSO4, so we will add this freshly prepared FeSO4 in the acidic medium, because we are adding the H2SO4 also. So in this acidic medium. Okay, so now let me complete the equation. As I told you, this is H plus, that means it shows that it is an acid. So if it is acid, it will give you water for sure. Got it? We made. Now NO3 is in +5 state, isn't it? And here it is +2. Any doubt in this? So now this is in its maximum. ये maximum में है. So if it is in maximum, that means it will go reduction. It will undergo reduction. Yes. So it will undergo reduction. What it will form, we'll decide it later on. Okay. And this is if it goes and undergoes reduction. So obviously this will undergo oxidation. Got it? And it will be better if I will write in this +2 state form as like in the ionic equation. Otherwise balancing will be there to, we are supposed to like balance. So let it be +2. Okay. So I'm not taking FeSO4 completely, ion just, because this is the ionic equation. Okay. So Fe +2, and I told you that if it undergoes reduction, so obviously this has to be oxidized. and Fe plus 2 oxidize. Okay, which state? We know that Fe can show plus 2 and plus 3 state only, and 0 state. So maximum is plus 3, so let it be Fe plus 3. Sorry, I should write it here now. This is Fe plus 3. Okay, this is. Now what product we will make as a reduction, reduction of this NO3 minus? What product? Think of it. Let me open the chart, that chart. Yes, so if we see, here it is. So this is NO3 minus. That means कुछ भी हम बना सकते हैं, any compound we can form. So quite clear है कि NH3, N2H4, NH2OH we will not form because it is hydrogen is there and we are not getting hydrogen. Hydrogen is converted into water, so that's why these three will not form. Now we have this N2, N2O, NO, N2O3, N2O4. Got it? So in that case, I've told you that this is the stable one, yes, and this is the stable one, and this is the stable one, last one. But the thing is that here, exceptionally, a new product formed. We can make all of this, but specifically this in the brown ring test, it gives this NO. ये NO बनाता है. Got it? This forms NO. And here NO actually जो होता है, this is having like we have to consider this is NO, like nitrosonium. We say it is as a nitrosonium ion. We say. Got it? So if what next, this NO, ये जो NO बना nitrosonium ion, this will react with this Fe, जो whatever the left over there, Fe plus 2 जो भी बचेगा उसके साथ is this NO, and the 5 molecule of water will react to form a complex. This will form a complex. Here it is Fe, and this will be H2O whole 5NO. See, this is quite contradictory. ये चीजें जो है ना काफी contradictory हैं. It like once you will do that coordination chemistry, where this, if I am saying sonium EM ion, if any word ends with the EM ion, that means it must have positive charge. So positive charge we are supposed to mention it, because as I told you, nitrosonium, in some books it is like quite contradictory that this they say it as a nitrosyl ion, like neutral ion, but it is not neutral, it is +1. And in this case, if I will ask that what is the oxidation number of Fe, so you have to keep in mind that oxidation number of Fe in this complex is +1. Got it? ये +1 होता है. So this thing you have to keep in your mind. और ये तभी possible है when this NO is in +1 state. Then only it is possible, otherwise it is not possible. Got it? So that's why we say it is a nitrosonium ion, and it must have a charge over there. So it is not giving the NO nitrogen oxide जो हमने बनाया था, it is not giving that one, it is actually forming nitrosonium ion. Got it here? समझ में आ गई बात? Okay. So now this is the brown ring test, and now we have to start the new element of the 15th group, that is phosphorus. So let's start with this. Okay, so let's start with this phosphorus. Phosphorus, some important points for about this. So just introduction. Phosphorus is found in allotropic form. We know that the form different form, and that are white phosphorus, red phosphorus, and black phosphorus. Okay, white phosphorus जो होता है, that is white waxy liquid. White wax is solid. It is poisonous and insoluble in water. But if we see the solubility, it is soluble in the inorganic solvent like CS2. Got it? It is highly reactive as it exists as a discrete form P4. I have explained you that when the structure of N2 and P4 I have explained. So P4 exists as a discrete form. That's why it is highly reactive. If you talk about among all phosphorus, like white phosphorus, red and black. So that white phosphorus is in discrete form. What does it mean discrete? I will explain in later on. So that's why it is highly reactive. Okay, now if we do this question, this is very important reaction of this phosphorus. And we have done in class 11th also this reaction, and you faced lots of problems in balancing. Yes. So let's see. White phosphorus, when boils with NaOH in an inert atmosphere, undergoes disproportionation reaction to give PH3 and NaH2PO2, sodium hypophosphite. This reaction is called disproportionation reaction. What it will happen? It will give this. I have explained you about the oxidation state of phosphorus, isn't it? Let me explain it here. This is -3 to +5. So the -3 is PH3 is the -1. Got it? And again, if we'll go through, this is the +5. Okay, and if we check this one, this is -6 +3. It is +3. Yes, got it? Similarly, it goes like that. So what we will see in this, again, this and this are the stable one, and this is although this one also. Okay, stable one. So it will give P4 is here. So if it is here, so that means it can be oxidized like this, either oxidized, and this can be reduced also. Yes. So reduction ke liye the stable one is only PH3. So what we will do, we will make this PH3. Clear? Any problem? Now for oxidation. So although I told you that I have told you that this one as a stable one, but in this specific reaction, it will give you +1 state. +1. So this is H3PO2. So instead of this H3PO2, this is H3PO2. This one hydrogen will be substituted with this Na because Na is over there. Got it? So this will form NaH2PO2. Done. So what you have to keep in your mind that when P4 undergoes disproportionation, it gives. So there is only one product, reduced product, so only one product is possible. And oxidized, it gives the +1 oxidation state. That thing you have to keep in your mind. Got it? And okay. So now, if it is in ionic form, we are writing in ionic form. So what we will write? The same thing it is. This is not going to change. And here, ionic form, we will remove this Na. And it will be H2PO2 minus. Got it? So this is the reaction of P4, like disproportionation reaction of phosphorus. So I hope it is clear. Yes, and it is what we say. It is disproportionation reaction. Example of disproportionation reaction. Now let's do with the compound of phosphorus. And phosphorus for the nitrogen, so we have done that it cannot show, it was not unable to show the +5 state, isn't it? But here phosphorus can show +5 because it is pentavalent and it is possible. It has d orbitals, it has like it. So now we are going to start with this compound which will show compound of phosphorus, and the oxidation range will be -3 to +5. Got it? So in that nitrogen, we have done that nitrogen cannot show +5, but phosphorus will show because it has d orbital and it can expand its octet. Okay, so let's similarly we will make the compound like NH3. Instead of NH3, we can make PH3, where this is -3. Then it is P2H4, this is -2. P4, it is 0, +1, -1, it doesn't show. Then H3PO2 +1. Then H3PO3, it will be +3, H3PO2 +4, and here H3PO4 +5. Got it? So these are the compound of phosphorus, we can see. Now, as I have explained in that ammonia case, that phosphine can also exist as phosphide P-3. This is phosphide, and it is possible only when it is with the metal. Got it? Now, what else? It can form PH4. Phosphonium ion. This is as it was ammonium ion, so here it will be phosphonium ion. Clear? And again we can say that on hydrolysis, this will give you PH3. Clear? Now if we will discuss about this is the -1 oxidation state. Here it is, so we can say that it is the what? It is the reductant. Yes, because it is in the least one, so it acts as a reductant. And this one is +5, so obviously it will be oxidant. Okay. And one more thing I just want to tell you that okay, about this H3PO4. This can, if it is in form of acid over here, it can exist as a oxide also, like P4 or it will be P4O10 plus 5. Got it? Like now this can be written as a, or like on ion form it can be written as H2PO4 minus. Okay, or it can be written HPO4 minus 2. I'm removing one hydrogen and putting the charge over there. Or I can write PO4 minus 3. So another way we can say, if phosphate ion undergoes hydrolysis, it will give you this. Yes, hypophosphoric acid. This is known as hypophosphoric acid. Okay. This one is phosphoric acid. Here it will be phosphoric acid. In general हम H3PO4 को ही कहते हैं phosphoric acid, but to be appropriate, we can say this is the phosphoric acid, and this one is hypophosphoric acid. Hypophosphoric acid. Okay. Now again in this way, this is also plus 3. So like ammonia, again here minus 3, 0, plus 3 and plus 5 are the stable one. Okay, so H3PO3 की बात करें तो if it is exist as an oxide, it will form P4O6. Yes, plus 3 state. Or we can write in that ionic form. If I want to write it, it can be in H2PO3 minus. Yes. Or one more if you will remove, so it can be HPO3 minus 2, isn't it? And similarly on hydrolysis, this one will give you final this on hydrolysis. Okay, this one is acid में this is the least one, so least, so we can say phosphoric, this is phosphorus acid. Now you can say that this one is the least, this is plus 1, this one is the least. So according to the concept, this should be the phosphorus acid, but यहाँ थोड़ा exceptions है, so you have to learn this one is not phosphorus acid, this is phosphinic acid. Phosphinic acid. Okay, this one is phosphorus, this is phosphoric, and this is hypophosphoric because two oxidation states are there, so that's why. This is PS3 is known as phosphine. This is known as phosphine. So as I told you, this one will be reductant and this one will be oxidant because it is having higher one, and in between whatever it is, this is redox. In this, out of all this redox, the P4 is the most one, like shows the disproportionation reaction. That means both the oxidation and the reduction is possible. Although this is also used, but this one is most important. Okay. So now the next concept is structure of phosphorus compound that we will do in tomorrow class. So till then, thank you class.